Um, I am Fran Stallings. I've been a storyteller since I was a kid. I trained academically in biology and I taught university and I did postdoc research, that kind of stuff. So many of the stories that I tell are from a biological,
Brain bug.
they're
Now
on
we
the
have another problem. The brain bug is almost empty.
biology side, but I also have worked with uh, other scientists working in different fields on science communication using stories. I convene an international group of tellers, including many people from Asia and Europe, and we talk every other month on how to approach different topics. And of course, I work with the Eco Tellers group in the National Storytelling Network. Let's see. Good. Here come some more people. Okay. We've got a good sized group. That's great. Well, telling science like a story involves two things, one of which is knowing the science. And that's where a lot of us, my dear colleagues, may not be as strong as we'd like to be, but we have the opportunity to research our stories, and I'm going to be offering a handout that's in the stuff that you can click on in the schedule that will suggest some sources for stories that you could use to communicate this. Then the next thing is to tell it like a story because, as we know, stories have great power to make people pay attention and listen and retain what we have told them in the story, which reinforces why it's so important to make sure that we've got the science correct and straight. Even when they're talking animals in the story, we have to be sure that the science message is
Hmm.
correct. I would like to know, um, of those of us here, we got me and 14 other people. Are we all primarily storytellers, or are some of you scientists or engineers before you got into storytelling? I know Judy has worked with NASA for years. Um, can you write in the chat which part of there's biology, which of course is zoology and botany. There's okay a math teacher logged in the chat, um, physics, chemistry, astronomy. What is the angle that you are especially interested in communicating? Research librarian, very good.
Mhm.
So a research librarian has to be able to find information for everybody, I guess. Cosmochemistry, hooray, Judy. Wow, that's telling what's in the space dust that they bring back. Other people, if you are primarily a storyteller, but are your interests more along the line of biology or physics or math? Here's anatomy and physiology as a speech pathologist. Oh boy, that's very specialized. Always scared of science. Unfortunately, that's apt to be because we were taught science in school by teachers who were scared of science. They often,
Hmm.
like my high school biology teacher, literally told us, write this down, and he said, science is an organized body of facts. In other words, listen, remember, let's see, listen, record, memorize, regurgitate. As though that's all there was, that's the amount of science there will ever be. And those of us who aren't good at memorizing didn't have much inclination to do it that way. Okay, mostly natural biology and astronomy, and more on, yeah, Tony Hartman, great. Let's see.
Mhm.
NASA Apollo oh wow, bet there's stories there. Math, teachers scared of math. Bird watching and bird lives. kitchen
Mhm.
stories with science. You know, if you like to go hiking, if you garden, if you are a bird watcher or an any,
Mm,
that is science. That is the foundation. Paying
mm,
attention and noticing what happens and trying to
mhm.
figure out how it works. Natural world and conservation. Very good. Okay, I want to tell you what my plan is for today. I want to talk about three different angles for using different kinds of stories to communicate science, to hold people's attention, make it memorable, and get them interested and motivated with the stories. I'm going to talk about those three kinds. Then I'm going to demonstrate a story that I've kind of polished, and we'll talk about what are the elements of storytelling that I tried to use in presenting that story to make it interesting and not just a recitation, not just a lecture of facts. And after we've talked about that, I am going to give you some facts and challenge you in breakout rooms to work on how you would tell it like a story. Because the difference between a bunch of facts and a story is that a story tells us how to feel about the facts. You can't you can't change the facts, but in the telling of the story, you can change how people understand it, how they feel about it, and that can be important. Well, here are basically three different categories of kinds of stories. Of course, there are what I call not folk tales, but fact tales. And this is where you narrate an event that actually happened or the biography of a scientific discovery. How Alexander Fleming happened to discover penicillin. What happened that day when he came back to his lab, found the window was open, that his petri plates had been contaminated, but some of the plates had clear areas where the bacteria had died off. That story, and then how penicillin was developed into an important drug that saved so many lives in World War II, etc. That would be a fact tale narrative, talking about the early astronomers when they had little bitty telescopes and saw the rings of Saturn and saw the moons of Jupiter and so forth. Those would be fact tales relating a factual narrative. Now, you would develop that the way you do any other historical story, researching it, figuring out what angle to take in presenting it, making sure you have your facts correct and the names straight. I always have to review my notes because names don't really stick too well, but those are fact tales. Then there are metaphorical stories, and these could be fictional stories, but stories that convey a concept or a principle of science that's important enough that you want people to understand it. The story itself may be absolute fiction, like this one, which I guess was a joke, but this is the year for dinosaurs in the library, so I remember this one. A family went to a regional museum. There weren't many people there, but they were there to see the dinosaur fossils. And there was no one there to give them a guided tour, but the museum guard happened to notice the interest that they had looking at all of the different cases. He had been present when the guides had gone around and had given their lectures at each of the different cases. And so he thought maybe he could help this family. And he went over and he said, I see you're talking about this one over here. Yes, this one is 100,012 years old. He said, wow, 100,012. How do you know so precisely that it was 100,012 years old? He said, well, not 100,000, excuse me, 100 million. 100 million in 12 years. How do you know that? And he said, well, when I first started working here, I heard the guide say that it was 100 million years ago, and that was 12 years ago, so it's 100 million and 12.
Oh,
Now, I'm sure that's apocryphal or just a joke, but it makes the point about the difference between precision and accuracy. He was being very precise by adding the 12 years on, but the original date of 100 million was kind of an approximation. So being that precise about it really doesn't make sense. The difference between precision and accuracy. And there are many other stories that are that way. They are metaphors that help us convey one of the principles of science. And the trick is to find them and to see how they would apply to your situation. So that's the second category, what I call metaphors. And then the third category is what I call stealth science telling. And these are stories that may be fiction, but you can put factual information, correct factual information into the story and kind of slip it in, especially for kids. Like, for instance, Three Billy Goats Gruff that I grew up with, but as I got older, I began to feel pretty bad about the environmental depredations of those goats eating their first hillside all the way down to the roots, as goats will do if they're penned up. And so I include that in the story. And when I tell Three Billy Goats Gruff in my version of the story and have them trying to go to another hillside in order to destroy it, I've changed the story a little bit. The troll under the bridge is a park ranger, and she manages to dart the goats with anesthetic darts. Not, yeah, anesthetic? Yeah, darts that knock them out. And they take them to a place where they need the poison ivy and briars eaten out from under the power lines, controlling them with electric wire. So the goats live happy ever after. Anyway,
With lots to
that's an example of a fictitious story and maybe even a twisted fairy tale or nursery tale that has been used as the donkey to carry some scientific facts in, and I hope in a memorable way. Other stories that can be used that way for embedded facts, I tell to kids in Oklahoma, in the mandated curriculum, they're supposed to understand the concept of insulation. And people often think of a blanket or a coat as making you warm when really all it does is block the transmission of heat away from you. And so I tell a version of the Russian folktale about the snowman girl, who comes to life and comes to live with an older couple and has to be very careful to stay away from the fire, and can't eat or drink hot food that they offer her. No, 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 I'll melt. But when they offer to put her to bed under lots of blankets, she accepts those because they insulate her and protect her from the heat that's coming from the fire. So that is a stealth science tale, slipping some science principles and facts into a story. Any questions about those different categories? Because I want to give you an example of a story that I developed from news that I found actually first from BBC, and then I researched the sources of the story. This is a story that illustrates the fact that science is not a collection of facts, it is a process where you must be skeptical and logical and empirical, practical based. I'm going to tell you a kind of concise version of the story, and I want you to listen and listen for the storytelling style elements and techniques that are used in this, because we're going to discuss that. That's important to have at your fingertips when you develop your own stories. In the 1960s, the French naturalist Theodore Monod came to the landlocked nation of Mali in Africa to study the Tuaregs. They were a Muslim tribe of pastoralists. They had herds of goats, and they went from place to place, feeding their goats on whatever they could find. He was fascinated with their life ways, their language, their folk tales. But when they showed him demon holes, he was skeptical. They said, "You see, in the dry lake beds, you must never pitch your camp here because the demons will come up from underground and they will burn your tents and they will kill you." Demons. I do not believe in demons. I can't do a French accent. I do not believe in demons. Surely there is a natural explanation. But they took him to show the demon holes in the dry lake beds. Now you must understand that Mali is a nation that is Sahara Desert in the north and tropical jungle in the south, and in between is an area called the Sahel. The danger in the Sahel was that the desert was expanding with every drought season. The dry lake beds were valuable land. Years and years when there was water in the lakes would deposit nutritious sediments so that when a drought year came and the ground dried out, farmers wanted to move in, the resident farmers wanted to move in and plant that land. And the Tuaregs, of course, wanted to graze their goats in those dry lake beds, but they knew never to camp there. Well, they showed Monod these cracks in the earth. The dry lake beds, it had been drought the last year or two, and the earth had cracked, and from down under there, sulfurous smoke and fumes were rising. And when he looked down into the cracks, sure enough, the fires of hell were down below. He looked at the ground around those cracks. It seemed as though the heat was advancing across the dry lake bed, and where it had been, the earth was transformed into different kinds of stone, a kind of a metamorphic transformation that he knew from geology took a lot of heat to do. And he remembered having visited the places in Italy where there are active volcanoes. And he had seen the fumaroles, the cracks in the earth with steam and smoke coming up. And he said, "Aha, I use my logic, and I know this is not the demons. This is merely there is some magma below the surface, and it is heating the land and causing this. You can see the red hot." So he had a logical explanation for it, and when he published his research, he told about finding this evidence of volcanic activity under Mali. Now, Mali's in Western Africa. There's lots of volcanic activity in the eastern part, around the Rift Zone, Tanzania, and so forth. Kilimanjaro is a former volcano, but there had been no reports in Western Africa. But on the basis of his reputation as a naturalist, this was published and it went on the maps as evidence of volcanic activity. That was back in the 1960s, but in the 1990s, the government of Mali became very nervous. It was another drought period. Again, the land in the dry lake beds was in demand. The farmers from the south, mainly Christian, the Muslim Tuaregs with their herds coming in from the north, there were clashes and conflict over that desirable land. And meanwhile, the heat front was working across the dry lake beds, centimeters per day. It was advancing, killing off the browse for the goats from the roots up. It was burning. And this advance had the government worried. What if it meant there were going to be active volcanoes? How many villages would have to be relocated? What would they have to do? And so they hired some volcanologists from Scandinavia, Norwegians who came in, and they were skeptical and they were logical, but they were also empirical. They interviewed the farmers who lived around there, and they found out how the lake beds became like this during drought, but then in wet seasons, no more no more demons. Volcanoes don't usually act like that. And then they did an empirical experiment, a groundbreaking experiment with shovels. They dug down and down into the lake bed, and the deeper they went, the hotter it got, and then the cooler it got, which didn't make sense if there was magma under the surface. And they discovered that what they were seeing was peat, dead plant material, buried under the dirt, that when the ground was so dry it cracked and oxygen could get to it, spontaneously combusted, and it was burning underground, heating the soil, burning the plants, sending off those fumes. But unlike a volcano, you could stop its advance by digging a trench. Science is skeptical, logical, and empirical. That's the story of the demons of Mali. Now, I would like you all to have a chance to think about the way I told the story and any techniques. And so I want to put you into, can I do this? I want to, where's that thing? Not that. Here. Breakout rooms. Okay. I would like to put you in breakout rooms and have you discuss what did you notice about the way the story was told, what storytelling techniques. And I am going to ask you to be in the breakout rooms. Let me see. It is okay. I'm going to give 5 minutes for you to discuss together about how this differed from a dry lecture. And when we come back, then maybe we can brainstorm a list of what these were. So I'm going to create the breakout rooms and invite you to participate. Good, I hope.
Yeah.
Welcome. Welcome back. Sorry to interrupt you. I could see that people were still talking, which is great. Now, if I want to hear, what did you spot as being relevant to the storytelling techniques and styles? And you can use that react button down at the bottom, that heart-shaped thing. Click on that to raise a hand so that that'll put you in order and we can get some feedback. Okay, Stephanie?
So we enjoyed the fact that there were people involved to make it relatable.
Thank you. Yeah, the human angle. We being humans, that's what we're interested in. Thank you, Stephanie. Tony?
Well, we noticed it was not only were there people involved, but there was emotion. There was an emotional perspective. Like, why was this land so important to the goat herders? Why was it so important to the farmers? And what was going on in the minds of the various scientists? Because they would say, no, this is a great story and everything, but there's a logical explanation. So we're going to find out what the explanation is.
So there was something at stake because if it's just there are these people and they're doing this and nobody cares, it's not a story. We haven't engaged. Having something at stake is helpful. Let me see. Michael, you have your hand up?
Yes, we had a number of different comments, but one was how how well you told it step by step so that we could follow it. And therefore, it made sense logically that, oh, if you have a crack, if you have plants, then you have fire and those kinds of things. And the way that you just incorporated the whole idea of stories, but it was really about science. That was a big one. And I think Judy said, no matter what you say, it's good.
Well, thank you, Judy.
Uh,
Thanks, Michael. Tom?
uh-huh.
One of the things that we noticed was you did some honor to the concerns of the Tuaregs and the people that were involved, despite the fact that they didn't have the right answer. You didn't start with, well, they must be wrong. You started with, they observed this, this is what they practiced, this was their belief. And by doing that, it turned it into kind of a mystery to be solved as opposed to just facts to be spelled out.
And Fran, that was something that we referred to a couple of times about it was like a mystery, like you're telling us a mystery story. And that's what science is with hypotheses and theories, whatever. But if you tell it as a
Right,
mystery, it really
right.
connects the audience. So,
Isaac Asimov has commented that the most interesting thing about a scientific search is not when you say, Eureka, I have the explanation, but rather when you observe something strange and you say, that's funny. That's the exciting thing. And scientists go after it like you throw a ball for a dog. Tony has a hand up.
Yeah, I was thinking what was nice about the story was not only did we learn the science and we even learned some of the history, but we also learned some of the cultural beliefs and attitudes of those people.
And
So it was more than science because we were learning science, but we were learning culture and we were learning history at the same time.
And actually, if you watch the news, Mali is currently and has been, I mean, ever since the time of this event, has been torn between the Tuaregs and the farmers. And because the Tuaregs happen to be Muslim and the farmers mostly are Christian, people call it a religious war. It's about
Not.
resources.
Yeah.
It's about resources. And that's, that's a whole
That's a whole
additional
nother
topic.
bag. Yeah.
Yeah,
Right.
that
Yeah.
affects all the other things that people are doing. Well, thank you.
Oh,
You've caught the issues that we need in order to make our science stories relatable. They have to be about people. In order to make them seem important, there has to be something at stake. What's going to be lost? What is there to gain? What could change? It's not a story unless something changes. And so you've you've spotted the essential things we have to look
yeah.
for.
I,
Jay?
I think it was rather cool, though, that you didn't downplay Mr. Theodore that went out in the 60s. I mean, it was like going down the wrong road and having to discover the right road, that they went back and looked at it again.
Right.
And to me, it's like the older brothers going down or just not helping the person along the road. They
Right.
just go and assume they're going to be able to find everything and figure it out themselves. And
Yeah.
yeah,
Yeah.
they went back to say, well, let's look at this again. Maybe I do need to stop here and look.
And that's one of the things that makes science stories difficult, that it's never over.
Right. Yeah.
Because we continue, as more information comes along, we may have to scrap that lovely phlogiston theory or whatever it was and work out a new theory that explains things better. And so we can tell a story even with our fact tales about how somebody discovered something. It might have been wonderful. It was like when Thomas Midgley discovered that you could use chlorinated fluorocarbons as a safe refrigerant that wouldn't blow up and wouldn't kill people. That was terrific. And think of all the wonderful things that refrigeration has brought to us. Air conditioning, for one, safe
Mhm.
food transportation, safe medicine
Mhm.
transportation. It's unfortunate that Freon almost destroyed the the
A- Atmosphere.
atmosphere, yes, the
Hmm.
the layers of something layer.
Ozone.
Ozone layer. Yep, words. And anyway, and it was a good idea at the time. He also helped to develop tetraethyl lead for gasoline. But we sometimes we discover these things later. Well, I want you to have a chance to mess around with a story. And so I'm going to give you a, as dry as I can, a lecture on a mathematician who lived a long time ago and whose work was very important. And let's see how you would, you don't have time to go online and research a whole lot about this. So you're going to have to make it up, but I'm going to put you into other breakout rooms after I give you the facts of the tale and see what you come up with for a story about Fibonacci. Now, you may have heard the name Fibonacci as the name of the guy who popularized what we call for him the Fibonacci series 0, 1, 1, 2, 3, 5, 8, 13, 21, where each successive number is the sum of the two previous numbers. It's kind of fun to mess around with that sequence. And I've known a lot of elementary teachers who think that that's cool, and apparently kids are fond of it. And I got to wondering, who is Fibonacci and how did he come up with this, and did he do anything else? Well, here. His name actually was Leonardo Bonacci, or Leonardo of Pisa in Italy. He was born around the same time that they put in the foundation for the famous Leaning Tower, but that's most of what most people know about the town of Pisa. Fibonacci is a nickname that was given to him by a French historian, and it comes from Filius Bonacci, son of Bonacci. He was born in 1175, quite a while ago, and his father, Mr. Bonacci, was a wealthy Italian merchant and apparently a kind of customs official for the Italian government. He directed a trading post in North Africa and what is now Algeria. And in this trading post where he took his son Leonardo along, Leonardo got to see things from outside the European world, because there were ships from India, ships from all over the Arabic world. And he was fascinated to see what those people could do. Especially, he had always loved mathematics, and he noticed that the skippers of those ships could add up and subtract and calculate what customs taxes so much faster than the Italians, who were still in the late 1100s into the 12. They were still using Roman numerals. Have you ever tried to do arithmetic with Roman numerals? And he saw that they were using a system that is properly called Hindu-Arabic. We maybe call them Arabic numbers. They came from India, Hindu, and they had the digits 1 through 9, and not V's and 111s and X's and stuff like that. They had the digits 1 through 9, and they had a 0, which the Latin system, the Roman numerals, had never done. This made not only adding and subtracting so much easier, but it made it possible to multiply. He thought this was cool and he tried to popularize it. In the year 1202, he wrote a book called Liber Abaci, the Book of the Abacus, or a book of calculation, to try to popularize the Hindu Arabic numerals in Europe. He happened to also mention the Fibonacci series, what we call the Fibonacci sequence, but it has been found in Indian mathematics long before his date. This book was, of course, written in Latin, which everything had to be back then, and so it didn't get down to the common people too fast. But it is Leonardo of Pisa, or Fibonacci, that we can thank for introducing this system of numbers that we depend on so much now. He died roughly in 1240, most likely back in Pisa. Do not confuse him with Leonardo da Vinci, who was a couple hundred years later. And I think his story should be honored every time we have to add and subtract. So those are the basic facts. He was the son of a wealthy merchant and customs official. He got introduced to foreign ways by hanging out with his father around the port and getting to know those sailors. And he wrote this book. So what would you do? Think about that. What would you do to make this, to introduce a human element, to make something at stake, perhaps, so that we would care about this system of numbers? And to make, how would you tell it? To make it memorable. So I am going to try to put you in breakout rooms. I dropped in on several rooms and people seem to be having trouble with this.
Are you sure that was 10 minutes?
No, I came back early because a couple of the groups were kind of bogged down.
Mm.
So I thought
We
maybe
were having lots of fun. Can we go back?
Oh, great. Tell us about the fun you were having. What did you do?
Well, they talked about how he was exposed to all these different cultures by being in Algiers and meeting these different seafaring people, and they brought their own perspective of the world to him. He didn't get to travel, but he got the benefit of all that, and probably made him curious and interested and broadened his perspective of the world and allowed him to come up with this new mathematical theory that was unique. And how nice was all that?
Ah, good. Okay. Now he is, yeah, Tony?
Well, I think we need to be careful with this because as Patrick is saying, well, he came up with this idea, and he really didn't come up with the idea. The Hindu Arabs came up with it. So if we're going to be factual about this, we need to make sure that we have given correct credit to those people. And we can't be loose with our terminology. We can't say, well, this man came up with the idea of Arabic numerals, because he didn't. He is the man who told the Western world how to use Arabic numerals. And
that's an important distinction, Tony. And there's a lot in the history of science of the people who published something and got the credit and sometimes the Nobel Prize were not necessarily the ones who had actually done the work.
Yeah, right.
And so
Right.
there are more and more stories that are coming up about especially women who did the work, and then their counsel, their advisor or someone else got the credit and the prize.
Wrote the paper. Submitted. Yeah.
Well, my first thought was, you're talking about math. A lot of people are math phobic. And so I think we have to give them a reason to care what we're going to tell our story about. And I just came up with the beginning of the story. And mine is just, can one man change the world? Well, in 12,002 AD, one man did.
He made a
And I
start
think
anyway.
given our feeling, a lot of us are feeling like we can't change anything, we can't make a difference. Well, here's one guy who wasn't even trying to change the world, but he did. And so I want to put a personal, relatable
Yes.
spin on it
Uh-huh.
before I hit him with the facts. Oh,
That
and we also talked about how a lot of people, younger people, they don't know what a Roman numeral is. They don't know how to read a Roman numeral, nor, like Stephanie said, can most of them read a numeric clock.
yeah, yeah.
So there's going to have to be a tutorial in here somewhere.
Right. Now, I work with a second grade teacher who definitely teaches Roman numerals to the kids, if only to boggle their minds to see that there is a different way to write numbers. And
No, in one of my math classes for punishment drill, the prof used to make us calculate in Roman numerals.
ah, and if you've ever had to do that, you really appreciate the Hindu Arabic system. Now, remember what we said before, that the important thing is to make the story human, make it relatable. And so I would just suggest that if you wanted to do this story, you might look at this kid who's tagging along with his papa. He came from Pisa in Italy, and now he's crossed the Mediterranean to Algeria. And he's in this port with all these strange people. And apparently he was let to run pretty loose and talk with these strange, and you could really make it kind of exciting. We don't have a lot of detail about what his childhood was like, so this would be historical fiction, but you can kind of make it relatable along that line. And what was at stake? Well, when he saw how hard it was for the European ship people to make the calculations, how hard it was for his father to check their numbers, and then he saw the ship captains from the Arabic countries just doing it, that would make a difference. We are, of course, running short of time. I would like to, let me see, I'm going to share my screen, I hope. Here we go. And this is the handout that's in the on the schedule for you if you want. But it's a suggestion about different places where you could find articles and background that would give you ideas for stories that you can use. And check, some cute true stories really are too good to be true. Check them out, because there's a lot of very cute garbage out there these days. And so do go to Snopes or whatever and check that the fun, interesting science story is actual. And then here's some resources about different books about doing science storytelling and storytelling about nature. And then here's some collections of biographies of scientists that might be useful. And if you are working with schools, you can find out what the topics are, the content and the principles that they're supposed to be learning. You can find that out by looking up the academic standards for the state that you are working with. And if you want to get a look at some stories that have been hacked on and are there for the telling, go to my website, to the Earth Teller Tales. These are, in general, they're environmental or biological stories, but for many years, they're about 60 posted there. They are columns that I wrote for a digital newsletter called The Environmentor, and each one pairs a copyright-free traditional or my original for you to use, but not to print or anything, for you to tell. A folktale type story with a science article. So you can study those and use them and whatever. And after someone has taken a workshop with me, I am forever after available if you have a question or if you're looking for something, I will do what I can to help. Any questions right now? Jay?
Fran, I don't really have a question. I want to just share an antidote, if I may, because it's out of my own experience. I got back from
An antidote cures a poison. Is this perhaps an anecdote?
maybe it's anecdote, yes.
Good.
I just got back from a family vacation with my daughters and a son-in-law to the Grand Canyon. And I had read several books about the Grand Canyon before, both picture books for kids as well as narrative long stories. And the thing, they laughed at me because when I saw somebody standing there, and I sort of talk to strangers pretty easily, and I'd go up to them as they sat there in awe of the Grand Canyon on the ridge on the South Rim. And I'd say, "Oh, are you a geologist?" Because one of the biggest things I discovered is a picture book, I think called a Grand Canyon, that went through the many layers of the stone and the many eons of earth that it was, as well as the fossils that they found in each one of those. And to me, it was fascinating because I thought that must be one of the important things about the Grand Canyon is what it shows of the earth and how it began and what was there at particular times. Now, that's not so tied in directly with science or with anything story, except my own experience and what I read in books. And to me, that shows the value of it because as we kept going, we went to the Antelope Canyon caves and learned about all the swishing and curling in the caves, which had to do with water and all that kind of forming. Anyway, I just wanted to share that with you because that's my own little earth science type story. Anyway,
All those layers, just think how many years it took to deposit all that sand or all that clay to make all those layers. And that's one of the things that convinced Darwin that it had been more than 5,000 or 6,000 years.
right, right.
He saw all of that. Yeah. Well, any
Betsy had a
other,
question there.
yeah, any other questions about this? You have to find the story that resonates with you, that interests you enough to put the time into researching it to make sure you have the science right, and then to tell it in a way that will grab your listeners by the ears. I have told the Fibonacci story to second graders when they were learning different notations. And the idea that a kid back then was so fascinated that he learned about this and he also worked on the number sequences. The kids were fascinated to think of another kid doing that. So it's not just a grown-up mathematics story. We are unfortunately out of time. We have been asked to return to the main room for a discussion about what we learned today and to prepare for tomorrow. I want to thank you all for coming. This was a great turnout. I think we had some good discussion, and I hope it gets you started thinking about what you can do.
Thank you, Fran. Appreciate it.
Thank you, Fran.
Thank all of you, and thanks to TSA for making this possible in spite of the World Cup and $500 hotel.
I like this format. I like being on Zoom.
Yeah, it is nice.
I like being comfortable and at home, but
Well,
I miss being able to hug other people.
Right.
just so you know, in the next board meeting, I'm going to recommend to John, who is the new president, that we continue this every year, not every other year, and that we continue to do it in the Zoom format. I don't know how seriously I will be taken, but I am definitely going to make that recommendation.
Well, I've enjoyed working with all of you, and I look forward to tomorrow. Thanks so much, and let's go back to the main room and see what other people think, and then I'm going to hit the road and drive home.
Oh,
See you
oh,
tomorrow.
well, drive carefully if you have to drive far.
Oh,
Drive
only-
safely.
Only about 150 miles this time.
Oh, where are you? Bye-bye.